Hey everyone, Nitesh this side. So let's start with the question. So the question is remove cover intervals. So you have given an array intervals where intervals I is equal to Li and Ri. Li basically represent the left side of the interval and Ri basically represent the right side of the interval. So you have to basically return the number of remaining intervals. Basically the intervals AB is covered by the interval CD if and only if C is less than equal to A and B is less than equal to D. So you just have to remove the interval that is overlapping between some other intervals. Okay, so let's see with an example. Okay, so let's take this example 1, 4, 3, 6, and 2, 8. And for this, we are getting the output as 2. So let's see. So this is our array, our 2D array 1, 4, 3, 6, and a 2, 8. Okay, now let's do it like this. This is our basically 1 to 4. This is the range of interval. This is 1 to 4. Okay. Now represent this 3 to 6. So this will be like, this will be at here, and let's say it will be here. So this will be my 3 to 6. Okay. Now let's write down this also, 2 to 8. Let's say this is 2 and this is our 8. Okay. So we are getting these three intervals and we need to remove that interval which is overlapping to other intervals. So if you compare this 1 4 to this 3 8 3 6, sorry. So as you can see, this is partial overlap, like not completely overlap. So we will not take this overlap or add it inside this. Okay. So let's take 1 4 to 2 8 also, and you can see in the 2 8 it also a partial overlap because it start from 1 and it start from 2. So we will not take it. Now you can easily see for 3 6, this is completely lies in this interval. So what will be our final intervals? So we have 1 to 4 and 3 6 is completely merged to 2 8. So our final interval will become 2 8 only, and we will just remove that 3 6. So our final output size is 2. Okay, so let's see how we can approach this question. Okay, so let's see how we will approach this. So first step, what we will like do in interval question, or like, is basically merging the interval. So we need them to be in the sorted order. Okay, so let's sort them on the basis of their start time. Okay, so after sorting, the array will become something like this: 1 4 3, basically 2 8 and 3 comma 6. Okay, so after this, what we will do, we will take one array as our primary owner and we will check with others. Okay, and whenever we see like it will overlap, so we will not increase the, because we don't need to return the output list, we just need to return output size. Okay, so let's say we will store this in a some variable. So let's take a variable as on, and we will only store the right pointer of that. So we will store this 1 4 in some variable. Let's call it as a right. So this will be our pointer. Okay, we will compare this with rest of our element. Okay, so our pointer will now start from here and we need to check the two condition. Okay, we will check if our right is greater or equal to your current. Let's say this is integer array, interval array, basically current I and your end. If this basically this 4 is greater than 8, then we don't need to do anything, we just continue from here. Okay, else what we need to do, else we just need to update our right to point to this pointer. Basically this will be integer of I1 and we will increase our counter size. Okay, so our counter will start from 1 basically because we have take first as a first interval. Okay, so let's see, let's demonstrate. Okay, so right now our right is 4 and we will start from here. Okay, from 0 1 2. So we will start from here. We will basically first compare this right is greater equal to integer I1. So integer I1 is basically your 8, basically right interval. If it is greater, so as you can see, 4 is not greater or equal to 8, so we will use this else condition. So our right now become, instead of 4, now it will become 8, and our counter size will increase by 1, so it will become 2. Okay, now we'll go to this interval. So we will compare this to our right variable. So as you can see, 8 is greater or equal to 6. So we will not do anything. We will just do continue. Okay, we will move forward further. So we are at here. We will move further. So we are come out of the loop and we got the final output as count. Okay, let's take one more example. Okay, so let's take this input and now let's first sort it. Okay, so if we sort it, it will become something like this, because we are sort on the basis of the start interval. It will become 1 2, 1 4, and 2 4. Okay, so what we will do, we will store this right variable in some a variable. So we will store in a right. We will start from here. We will check, and our counter is 1. We will check whether this right is greater or equal to this current. So as you can see, this is not greater, so we will update our right to 0.24 and our counter will update to 2. Okay, now we will move further. We will compare with this. So for this, 4 is greater or equal to 4, so we will not do anything. Our count will remain same and we return the output as 2. But if you see in this case, the output is 1. So that's mean we are doing something wrong. What we are doing basically wrong is, so when we sorting, we just sort on the basis of start interval. But let's say if start interval is same, then we need to sort them on the basis of their end interval. And end interval, in basically the largest end interval will come first and then smallest. So after sorting, it should become something like this: 1 4, 1 2, and your 2 4. Okay, now you will approach your same approach. So we'll store in a right variable. So this will be 4. Now we will compare it here. So we will check, is 4 is greater or equal to end interval? Yes, it is greater or equal to. So we will just move continue, and our counter is same as 1. So we will go up further. Now for this case, we again check with this, right? So this is equal to 4. So we will not do anything. We just remain same as it is and we return this output. Okay, so let's write the code for this. Okay, so our first step is basically to sort the array. Arrays dot sort interval. And what we need to do, we need to add one comparator also, because we need to compare the arrays. Public int compare, and we will do compare, only compare, not compare to integer array1, integer array2. And what we need to return, we just need to return a1 start interval minus a2, give the smallest interval basically. And we need to add one condition also: if a1 0 is equal to a2 0, we just need to return a1 1. Basically we need to return in reverse order, so a2 will come first and then a1. So this will sort our array. Okay, now let's write the code for our logic. So we'll take a right variable, which will be from start, so it will be intervals 0, 1. We take a counter, which will start from 1. Now we'll loop over our array, so we'll start from 1, intervals dot length I plus plus. But we will compare if right is greater or equal to intervals of I. That means it is overlapping on our same existing interval, so we don't need to do anything. It will be overlap. Okay, now this will become, we will just do continue. Else what we will do, we need to update our right intervals. Okay, intervals I, 1, and we increase our count. After this, we return just count. Okay, let's run the code. Okay, so this is accepted. Let's submit the code. Let's see. So we have done something wrong. Let's see. So the mistake is basically, if you see, we have done A21 minus A1, we need to do the end interval. So this is a mistake. Let's submit it again. Okay, let's see. So this is submitted. And the time complexity for this, we just do the sorting of the array, and for sorting it will cause you nlogn. Other than that, we just do the order of n over the loop. So that's the time complexity. Thank you for watching my video.